final year project is future learning. Let's break into what's future learning and how we try to improve existing work. Here, can you identify this image? Most of you can't, but now you can able to identify. It is pangolin. Now you experience that human can identify the images using small number of examples, but computer struggles to do this kind of task. Here the future learning problem rise. Future learning is a machine learning model that can do the task using small number of training data. Now let's look into how machine learning trained and tested in future learning task. Let's look into the training phase of future learning model. Here there are some new words: support set, query set, and embedding. Let's break these one by one. Support set means images given to learn the task. Here model is trained to classify the dolphin, bird, and dog images using 2 images per class. Query set is question to the model after learning about the classes given to the support set. The embedding space is a space where images are represented in vector form. For example, a 32 by 32 by 3 images can be represented in 512 length of vector in embedding space. Here, lengthy images are string to vector representation. This vector representation represents the unique feature of the images. Now let's look into what's happening in this diagram. In the first step, support set images are fed to future learning model to map embedding space. Then the query set is fed into the model and mapped to the same embedding space. After the classification of query set, loss will evaluated, and from the loss, model will try to improve itself. Next, let's look into the testing phase of model. Support set images are fed to the model for mapping in embedding space. In the next step, query images fed to the model for classification. Classification is of the images typically done by finding the Euclidean distance between the support classes and query image. From the calculated distance, closest class label is assigned to the query. This is how commonly future classification works. Next, let's look into our approach for future learning. We know that we have less data in future learning. To mitigate that, we use generator to produce extra artificial data points. It's illustrated in A. In B, circles are the true features and the triangles are the true class embedding. Stars represents selected feature mean embedding. Our selected feature mean embedding should closer to the triangle for better classification. In C, now we bring the generated features with original features and update the new mean. From D, we can see the updated feature mean moves closer to the true class embedding after bring the generated feature. Now let's see what we did in detail. For training, the image features are randomly selected and the class level descriptions are associated to the image features are fed into the text feature extractor. And the class level embedding mean of the feature is fed to the generator as shown here. A classifier, discriminator, and cosine distance modules are used to train the generator. A classifier must make sure that generated features are same class as input feature. The discriminator makes sure the generator generates the feature similar to the original input feature. And the cosine distance makes sure the generated features are closer to the true class level embedding of particular class. Now, this feature generator is connected with future learning architecture as shown here. Image features are extracted from support set images and textual features are extracted from support class textual description. Then extracted textual features of classes fed to the trained generator to generate artificial visual feature. After feature generation, we have real feature from support class images and artificial generated features from generator. Then by taking lambda weighted mean, we will get the final embedding for the support class. And we will use it for fusion prediction as we explained earlier in our video. From all of the above steps, we can able to beat the existing accuracies of some baseline papers. Thank you.